Okay, so good morning, everyone, or good afternoon, wherever you are. Welcome to our second series of this very important chemistry lesson for everybody. It's free. I don't think it's really difficult. So there are different ways you can get access to the materials in this class. So this is a very important topic in chemistry. I just went through the JAM syllabus. I don't know why JAM does that, but it's just too much. So this is like the syllabus in JAM, and for me, it's a lot. So this is where we are starting from. So annotate. So here is Alkanols. So that is where I started from. So you can see as wide as this topic is, it's really, really wide. So I tried my best to compress the notes in how many slides of the PowerPoint. So that's all you can see. It's so large, so many things to remember. But the secret here is that once you are familiar with the main chemistry, then the rest is history for you. So let's go back to our class and begin the show. Okay, I would have loved to talk about. I don't like displaying, working with this screen, but I just have to. So since you have the note, that's fine. So basically, just as you know of alkanols, alkanols are organic. Please, I'm not hearing the meeting, but I am. Oh, I'm in the meeting. Oh, yes. This is somebody says you need to connect your audio. Yeah, tap the mic button. Okay. So I guess if you can see his audio is really, he has not been able to connect his audio. Maybe it's his first time on Zoom. That's fine. Okay. So I guess it's time to mute. So please just stay muted so that we can have less distraction. Okay, so he has joined finally. He was the first person to be here, right? I guess the audio was okay. Okay, so I've muted everybody, so that's fine. Let's go. So organic chemistry, like they are just mainly from plants. So alkanols are also obtained from plants. Okay, so um I don't know how I'm going to start, but okay, let's just flow. Okay, so here the main thing that you need to remember or that tells us that this compound is an alkanol is the fact that it has this functional group OH. See? So that's an OH. So I've decided to write ROH. R here means R is the alkyl group or the RI group. So when you say alkyl, it's like CH3, like C2H5, okay, C3H7, okay, or C6H5. No, so I put 6 That's by when we say aromatic alkanols. So that's for that array. That's we call that one RI. Let me pronounce it RI so I can sound properly. So then these ones are now called alkyl or alkyl. So that's what the R stands for. So if it is the benzene substituted alcohol, so we call it RI groups. So if it is straight chains, we call them alkyl groups. Okay, um so again, from what I have here, I have a general molecular formula of these alcohols as CnH2n plus 1. Of course, this is just for the alkyl, or we call it aliphatic alkanols. So we have aromatic alkanols. So whatever this is saying, this is just mainly for the aliphatic alkanols. So those ones that contains straight chains. I wanted to like do alkanes, but based on the voting we had, people chose this topic more. So bear with me if you are just hearing these big words. Okay. So I try my best to be more explicit. So here so the N means 1, 2, 3, 4, 5. That's like the number of carbon atoms, okay, in the compound. So if you have N to be 1, N to be 2, N to be 3. So if you do your substitution there, so if N is equal to 1, you now have CH3, then yeah, when N is equal to 1, you have CH3, they have OH. So that's like the first member. So, like, let me just do a little bit um, when we talk about CH3, how do we pronounce CH3? So CH3 is an alkyl, so we call it methyl. So methyl, methyl. If it is number 2, if it is 2, so I say 2H5. So that's ethyl. If it is 3, that is propyl. So WAEC just wants you to WAEC and JAM, they're interested in the first 5. WAEC says the first 6 members. So if you are dealing with uh, methyl 1, ethyl 2, propyl 3, butyl 4, okay, pentyl and hexyl. So that's like 6, the first 6 carbons. That's what they're interested in. Okay, so even if for these alcohols, most of the time they're only interested in the first 5 if it is jam. So but when it comes to naming, okay, so you don't need to cram. Like some people will cram the first 10, but it's also good to remember the first 10, but nobody really cares. Okay, so that is what it does. So one interesting thing about these alcohols, like I'm going to be interchanging my name nomenclature. So I can call them an alcohol, I can call them an Alkanol. So like, yeah, when I mean Alkanol, I'm just like focusing my attention on the aliphatic. Okay, but they are generally classified as alcohol. So this is the way you draw the structure. Nobody cares how you draw the structure if you're writing JAM. So this is just what you need to identify that is a functional group. So once you have that, it is that OH that makes it a functional group. Remember, they must have, for it to be an alcohol, it must have only one oxygen. Okay, so in some cases, let me see if I can get a better pen. Yep. Okay. So in some cases, you see some people will see this card. You have C. Like, let me undo this. So you have COH. Then I have another one. Oh, see, is this now an alcohol? No, it is no longer an alcohol because it has an extra oxygen. So don't confuse yourself by, oh, but it has OH here. Yes, it has an OH, but it's no longer an alcohol. I think that as long as the extra oxygen is together with that OH on the same carbon, okay, so that means it is no longer an alcohol. So it becomes another thing, carboxylic acid. Yep. So if it is carboxylic acids also have OH, but they have an extra oxygen. So just take note of that very important. And then another thing I need to let you know and remind you is that once you are drawing your compound, if you are writing Y like this here, and you are drawing your compounds, and then you have earlier, so you can see around this carbon here, on each carbon, it is usually surrounded with 4 different bonds. I'm going to just cancel out the bond 1, bond 2, bond 3, bond 4. So every carbon must have 4 bonds. So let me just, so you take note of this very clearly. So just a quick one, hydrogen can only have 1 bond, just one, connected to it. Oxygen must always have 2 bonds. So it's either the 2 bonds are like that or the 2 bonds are connected to it straight directly. Okay, nitrogen must always have 3 bonds. So you either have 1, 2, 3. Okay, because it is organic chemistry we are dealing with. So just always focus attention on this. And then carbon, the next one that is very popular, must have 4 bonds around it. So once you know that, whenever you are drawing your structure, if you're writing Y, you need to draw, but if you're writing JAM, nobody cares. Just pick A, B, C, D. All right, so that's exactly what you need to know. So back to our alcohols. I just did that because of those who have just doing organic chemistry maybe for the first time, or who have never understood it. I think, yeah, so I've already explained this. Whatever that makes them an alcohol is because they have a OH functional group. And that OH functional group is called hydroxyl. And that is why also that hydroxy group. Another thing you need to know about it, because you are writing jam now, is the fact that you see that O and H together. See, I write it on my white side. O and H together. See, there's a bond between oxygen and hydrogen. Last year, we talked about electronegativity, electron affinity, ionization energy. It is this bond here that this single bond between oxygen and hydrogen is a very strong bond. Why? Why is it like that? Because oxygen is highly electronegative. So it's on the far right of the periodic table. So bonding with another element on the far left, like hydrogen, creates what we call hydrogen bonding. And it is that hydrogen bonding that makes alcohols behave in a very, very unique way. If in alcohol, so there are few questions that will always come out in this alcohol. Is that they give you a question about naming, they give you a question about, oh, what is responsible for its chemical property? It is that hydroxy group, that's the functional group. What makes this have a high boiling point? Comparing it to alkanes, it is still that hydroxy group, this OH group. So because of that hydrogen bonding in it, so that makes it have very, very interesting property. Oh, why is alcohol soluble in water? If you have been reading your past question, in recent time, you must have come across that question. Why is it that alcohols are soluble in water? Why? The answer is simply because they have a hydroxy group, that OH group there. That is what makes it have all these interesting, unique properties. Okay. Right. So this is just how to name some of them. So just a quick one. If you want to name alcohols, first thing you need to do, identify the carbon or identify the functional group. Here is only one. This is only functional group here. Here is only functional group. So that carbon that is holding the functional group, I like using that word holding because um, people understand organic chemistry in different ways. So if I say holding, that means carbon is that carbon. I told you it has 4 bonds, but there's a particular carbon that is directly connected to the OH, and this is the carbon here. Asterisk it. So that is our number one carbon. Always, always, yes. So it's always the number one carbon. So you have 1, 2. So since there are 2 carbon, so it is ethyl, okay, ethanol. You see? So that's what we call ethanol. In some cases, you can see ethanol. You see, why is it ethanol? Why is it not ethanol? Because there is a single bond in this compound, and if it is ethanol, there is a double bond. While syllables and jazz syllables do not care about ethanol, so just in case, if you are doing A-level and you begin to see ethanol, yeah, that's possible. Okay, so if it is 2 carbon, if it is 3 carbon, propanol, see, propanol, very simple. I can mention propanol, butanol, pentanol. Okay, so very simple. So that's how you name alcohols. So let's play around propanol. You see, pro means 3 carbon. If you want to draw it in WAEC, how would you draw it? Just, let's tell students, remember that there is an OH, propanol. Pro means there are 3 carbons. So connect all the 3 carbons together. First thing first, connect carbon 1, carbon 2, carbon 3. So propanol means that there is OH. So as a smart chemistry student, where do you put your OH? Oh, because you are used to Mr. Nkwocha, he puts his OH on the first carbon. Beautiful. What if I like to do something differently? I like students who do that. What if I draw my 1, 2, 3? I like to put my OH in the second carbon in the middle. Okay, that's also an excellent job. What if I choose to put it at the back? 1, 2, 3. Is it OH? I'm putting it here. So some people are so artistic. So whatever where you like to put it on, that's really fine. Nobody cares. That's how it works. So now the question is, the moment you put it there, that becomes your main functional group. That affects the naming. So let's start from the first one. This OH is in, according to me, because I'm a right-handed person, this alcohol, this OH is on my first carbon because I'm right-handed. If you see somebody that's left-handed, they would prefer to start from the left-hand side. Of course, that's unique. So where did you start from? At the back. So whether it's on at the back for a left-handed person or at the right for the right-handed person, that is carbon number 1. Nobody cares unless it is in the middle. Okay, so if it is is it propan 1 or propan 1 or means that the OH, this is 1 all means that the OH is strictly on the first carbon. So either you put it at the left or on the right. That means this is carbon number 1 and this is carbon number 1. So you can name from anywhere. This is carbon number 2, carbon number 3. So this is carbon number 2, carbon number 3. That's very, very simple and straightforward. If you have questions, just put it on the chat. It said please minimize the screen. Okay, I don't know what that means. I hope you can see my screen. Okay, so that is exactly how you can deal with that essentially. Okay. So what about this one that is the carbon is the OH is in the middle carbon? Well, how is this still propane 1 or fortunately no? Why? Because that carbon is a middle carbon, and so it becomes carbon number 2. So if you are naming it, it's going to be propan 2O. Okay, so that's straightforward. Okay, so I don't need to bug you too much on these alcohols. I hope that is very clear. You can be practicing, you can like grab a lot of questions online, anywhere, and practice this naming. If you are struggling with it, just send me, drop it on the chat on WhatsApp, and then I will answer it and mark it for you to see if you are correct. Okay. So before I move to this next slide, what information does that tell us? It simply tells that this OH can be in the middle or can be in the first. So since both of them, their names are not appearing the same way, they are strictly called isomers. Okay, which one did you just put? Which one is the propan 1 in the example you just did? The propan 1, I have 2 propan 1 here for the right-handed person. So this is propan 1 all, and this is also propan 1 all. Because like the carbon, the OH is directly on the first carbon. That is propan 1 all. You see, in WAEC, if you draw this, you don't get any mark because I have not fulfilled all righteousness by putting all the hydrogen in their rightful position. Okay, so I have to put all the right hydrogen 1, 2, 3, 4, 5, 6, 7. So put all the hydrogen in their rightful place and you'll be fine. That means you have gotten all your mark fully. Okay, so make sure that carbon has 4 bonds, oxygen has 2 bonds. So there is always where is the bond, second bond in oxygen? The second bond in oxygen is between O and H. And then this single other bond is connected to carbon. I mean in the closest carbon in the middle. Okay, thank you very much for asking that question. Oh, smart guy. Thank you for pointing that out. Very simple. Now that we have carbon, 2 carbons here, one on the right and one on the left, and they have equal distance to the middle carbon, automatically anyone can be first. This one can be carbon number 1, and so can be carbon number 2. Very simple. If on one condition, sorry, I said carbon number 2. This one can also be carbon number 1. So what changes? How can I be specific about carbon number 1 and carbon number 2? So if I do like this is hydrogen, 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 hydrogen. So the one on my left is equal to the ones on my right hand side. Automatically, any of them can be carbon number 1 for this second one I'm dealing with. Automatic assignment comes when I just come here and put chlorine. See, I put chlorine on the right hand carbon. Automatically, that one becomes carbon number 1. Automatically. So you put it on the heavier part. Okay, so very, very important for you to remember. Okay, so that's quite easy for you to remember. I don't want to do it too much. Yeah, just 1 mark. Usually 1 question that comes from it in WAEC. Okay, that's easy. So these are like other examples of Alkanol. So from JAM and WAEC syllabus, the one specifically JAM, I see these questions a lot. So let's say, how do we class? There are different ways your chemistry teacher must have classified alcohols. So the first way we can classify alcohol is, first of all, how many OH does it have? Can I have more than 1 OH? Of course, yes. Yeah, but if it has only 1 OH, that's the one that is very, very popular. So they are just called monohydric alkanols. WAEC question. You see, I'm being specific to the one that is WAEC and the one that is JAM, so that you always put that in mind. WAEC deals with a lot of monohydric alcohols. JAM deals with trihydric. Everywhere you go to JAM like this, of course, the common example of trihydric alcohol is glycerol. The glycerol that is found in soya bean, all those oil nuts, can see that's glycerol. So that's like the most popular one that you can easily come across. Yeah. even when you're making soap, that's still fine. So monohydric alkanols, the one that is most popular is ethanol. That's for the monohydric alkanol. Then dihydric alkanols, the one that is also popular is ethane diol, 1, 2. See, 2 carbon, 1 OH, then 2 carbon. So you see, so this is the dihydric alkanol that is very, very popular. Okay, so it's also that. So I'm giving you the ones that are popular. Ethanol for monohydric, glycerol for trihydric, and uh, ethane 1,2-diol for dihydric. Are there polyhydric? Yes, erythritol. Nobody cares about polyhydric alcohol, so just forget about that photo. I just wanted to, I put it here for you people to know that it is not just only mono, di, and tri. It can be poly, okay? So that is, nobody asks any question about polyhydric, so don't worry yourself about it, okay? So you can see how I usually connect all the carbons together, and all of them have 1 carbon, 3 carbon, 3 carbon, 1 OH, 2 OH, 3 OH. And then the other thing you need to know, how do I name it? Do I need to memorize the naming it? Yes, the naming is very simple. Just put, identify how many carbon, so it becomes prop, like trihydric, propane. Okay, so if it is ethane, so we have, if it is ethane, that means it has 2 carbon, 1, 2. So I have OH, OH. Okay, see, very simple. So ethane, 1, 2-diol. I've specifically indicated the positions of the alcohol. It means that the alcohols are on the first carbon and on the second carbon. You see, I put propane 1, 2, 3-triol. Means that the OH are on the first, second, and third carbon. So if I now come here, let me clean this a little bit. Let me play around this. So if I come here and put OH here, how does it affect the naming of this compound? It automatically affects it because it becomes ethane 1,1-diol. What does that tell you? That the OH, both of them are on the second carbon, on the first carbon, 1, 1, because that's what means. Well, that is what those 1, 2, 3 means. No waste of time. Let's move on. Yeah, I think, yeah, so this is another common way that, in terms of, this is what we usually focus our attention in, maybe as a chemistry teacher. What if, so this is a monohydric alcohols now. So what other way can I classify it? My teacher thought of primary alcohols, secondary alcohols, tertiary alcohols. Beautiful. That is also very correct. But that's like under monohydric. Sir, please, sir, I don't understand your explanation on mono and di. Okay, when I say mono and dihydric, it simply means that they have, mono means 1, di 2. So if an organic compound has 2 OH group, that means it's a dihydric alkanol. If it has only 1 OH group, that means it's a monohydric alkanol. For example, look at this monohydric. Look at this compound here now. It has only 1 OH group. Look at this, 1, 2, 3, 4. Okay, if I put OH here, I put OH here. So this automatically means that it's no longer a monohydric. It is now a dihydric. Okay, so that's very, very simple to do. Okay, so now focusing our attention on monohydric, because these are like the ones that are really, really important. The ones that are really important are monohydric alkanols. So monohydric alkanols can further be classified into primary, secondary, and tertiary. This is where we streamline our attention. Focus. We don't care about those dihydric and trihydric. We only use them for examples, and that's the only way the question will come out. Okay, the question does not go beyond that. So primary alcohols, secondary alkanols, tertiary alkanols. What does that mean? Oh, primary went to primary school. Funny. That's not really funny. Okay, so when it is primary, it simply means that the OH, the main thing that we came here to do, these OH guys are automatically on that first carbon. The moment you open the door, who do you see? OH. Okay, so that is what it means. But the OH can be hiding. Like on the diagram on the right hand side, the one I drew by myself. If the OH is in the middle, you don't see them immediately. You see, here, automatically is in the middle. You have to go from first carbon, second carbon, oh my God, then third carbon, but nobody cares. So this is OH is in the middle carbon. What does that tells us? it automatically changes the chemistry of everybody. It changes their name and it changes their chemical properties. I am, come on. You don't have to annotate on my screen. No, come on. Don't allow me to be making people to, why do I have to stop making people to annotate on my screen? Okay, but come on. This is not 2020 when people are still learning how to use Zoom. So, okay, so because of you, I've stopped the annotation for everybody. But that's okay. I'm forgiving you. So let me do the total. So here, the OH is on the first carbon. It simply means, remember what I told you that the moment oxygen is bonded to hydrogen, that is a very, very powerful bond there. That bond determines how the alcohol is going to be soluble in water, how it's going to react with sodium, how it's going to react with carboxylic acid. Wow, really? Yes. So do you know what? It's okay, I'll forgive you. Come on. Okay. So do you know I talked about that is where the reactivity of these compounds takes place. So how does that really, really come to play? Now, when I say reactivity, and you're already scared because Mr. Nkwocha will tell you the right chemical reaction. Come on. Yeah. That's actually the truth. So the reactivity means that is the reaction center. Anytime you are doing organic chemistry and you get to that functional group, that is the reaction center. If the functional group is a double bond, that is where all the chemical reaction, let me not say all, most of the chemical reaction are going to take place. If you are going to attach sodium, it is at that double bond. If you are going to attach fluorine, it's at that double bond. Or here, we are dealing with OH. So that means if you are going to carry out any reaction, it is at that position where you have OH. Let's say, for example, if I want to do any chemical reaction now, let me use methanol, COH. I put H here, I put H here, I put H here. If I want to carry out any reaction, I'm not interested in all this other H that is surrounding the carbon, but at the reaction center is a functional group, so this is where I'm going to come. So if I want to make any substitution reaction, I will come and substitute this hydrogen. Why? Why does it? Number one reason is because that is not a why question, just for you to understand. Is simply because that is the functional group. It is the functional group that determines the chemical reactivity of every organic compound. That's number one reason. And number two reason, and the most important reason, I told you that oxygen is highly electronegative. So remember that word. Electronegativity is the ability of an element to attract a shared electron. Oh my God. Shared electron, that means is a covalent bond because not electrovalent, right? Remember, if you forgot it, just go. Meanwhile, I have lots of videos. So if you guys are interested in all the videos I've been teaching in the past, instead of waiting for every week, one video, just let me know. I will push it out on YouTube video. I have so you know my YouTube channels. I can push all the videos I've taught in the past, so you don't have to wait until Saturday. Okay, so but that's for you, so you can go back and watch. So electronegativity. So this is a shared electron. This single bond here, the electrons in this bond here are shared between oxygen and hydrogen. So because oxygen is so powerful, it wants to attract this electron to itself. So it pulls the electron to itself. Guess what? What happens to hydrogen? You remember that hydrogen guy? Hydrogen has only one electron in its atmosphere, just one. We talked about that last period because the periodic table last week, just one electron. So if it pulls the electron away from hydrogen, what does hydrogen do? So hydrogen is now going to have H plus. So that means how can both of us be sharing something and you not take everything to yourself? Won't our friendship end? Of course, our friendship will end because how would you take everything? So the moment oxygen pulls all the electrons to itself, hydrogen is no longer left with any electron. Guess what hydrogen will do? Hydrogen will leave. So hydrogen will leave. Okay, let me just say hydrogen leaves, so making this oxygen negatively charged. So of course, plus H plus. This is what we call mechanism of a chemical reaction. This is exactly what usually happens. So when the hydrogen leaves, it means that this oxygen have not fully bonded. Remember that Mr. Nkwocha said that oxygen must always have two bonds. Now it is having an extra electron. So what happens? So it's not looking for an element that is interested in collecting an extra electron. Yeah, that's exactly what happens. So imagine if there is a floating sodium that has lost its own electron, a floating sodium positive, a floating Which other thing can we put? Of course, you cannot bring fluorine because fluorine is highly electronegative. Cannot come and put fluorine there. So, okay, maybe a floating calcium, a floating potassium, all those metals that are positive charge. So they are floating. So guess what? They would love to go to that electron-rich center and chill out, at least be stable and relax. So that is where all the chemical reactions take place at that point. Exactly, that is exactly what happens. So that becomes a reaction center. So do you know why I'm calling it a reaction center? Do you know how it affects these primary alcohols and secondary alcohols? So this hydrogen, does it stay alone? No, no. It has to say, okay, my brothers, don't leave me stranded. I am a good brother to you. Please help me, please. So it goes and creates a fight because we are in a chemistry world. Hydrogen creates a like Nigerian fight. So just gang up with your friends as a guy. Mo they go, mo they go. So now look at what happens there. Look at these hydrogen that are connected to this other. There are so many of them. Guess what happened? This hydrogen that is living, this our hydrogen that has been chased by oxygen. We look around and say all these hydrogen, all of you are equal. You are all connected to this to all carbons. So that means I can beg any of you. But guess what? They don't behave, all those hydrogen don't behave that way. So what happened here is that you see these other hydrogens that are close to this oxygen, they will become scared. See, I'm using a very interesting way to explain it to you. They become scared that, are you sure that this thing that oxygen has done to this same hydrogen, are you sure it will not still do it to this carbon? Of course, it will do it to carbon. It will start, so it has so much electron that it will start, that electron will start shaking the carbon together. I'm just being descriptive so I can easily grab it. Full stop. That like easy like that's this I'm explaining to you is three jam question now. Three Y question. Anyway, it's okay. So look at what happens. So this hydrogen that is leaving will go and say, oxygen. So oxygen shakes this carbon too because it's not having excess electron. It begins to shake that carbon. So do you get what? Okay. Since you are doing that, because carbon will not say, because I'm more electronegative than this hydrogen, let me kukuma just on a free way. Let me give this, man, let me just drag this electron and give to this guy too. That's exactly what will happen. So oxygen will say, I can no longer, let me draw it here. I can no longer bear this trauma. So look at what happened. So that oxygen that is very selfish, it has an extra electron. It will carry this extra electron and come here and bond it. See, look at what happened. It brings this extra electron and puts it. Think about it. When the extra When this extra electron comes, see what happens to this carbon here. Carbon is now having 5 bonds. Is that not a troublemaker? That's a big troublemaker there. It now has 5 bonds. Since it has 5 bonds, guess what will happen? That tells you, Mr. Nkwocha, you cannot be lying. Carbon cannot have 5 bonds. So guess what carbon does? It says, us hydrogen, though, we people have tried, though, but you see what oxygen have done. Please pardon me. I am going to do something like this. So now say, please, you guys should choose among yourselves. One of you must leave. So any of these hydrogen can leave. So this guy can leave, this guy can leave, and this guy can leave. So one of them, let me just go, just to balance this carbon, because carbon is our brother. He's one that has been helping us, saving us. So now, so then one of them should leave. So let me say this carbon leaves. That hydrogen leaves. So once that hydrogen leaves, carbon is balanced. So we now have our final product becomes CH2O. So let me just structurally draw it so that you see it properly. So we now have C double bond to oxygen, single bond to hydrogen, single bond to hydrogen. That creates another family of organic compounds. So guess what? We have created another fantastic family. So what happens to that hydrogen? That hydrogen goes and partners with the other hydrogen and forms hydrogen gas. So that hydrogen gas is lost. Now this carbon is satisfied. So here, oxygen has 2 bonds. In this, my final product, oxygen has 2 bonds. Everybody is satisfied. Carbon has 4 bonds. All the hydrogen here has single bond. And that is where it came from. Guess what? This has changed the chemistry. So classifying primary, secondary, and tertiary. Let me just show you. I think I have a summary slide here. Let me clean these things and show you what happened there. How did we come about this primary, secondary? I'm not interested in all this. Let me just, because of time is not, I don't need all this time. I don't need this one. Yeah, I think that's this side. So classifying all these primary, secondary, and tertiary organic compound is very, very simple. So look at what happened here. Primary. Look at the first. I'm going to differentiate it. Primary means here, one, but has two possible hydrogen that can leave. Secondary has only one possible hydrogen that can join this guy. Tertiary means no hydrogen. So guess what happened? So look at this, is very, very interesting. In the secondary alcohols, it has only one additional hydrogen because that hydrogen is in the middle. I don't like this slide. This slide is boring me. Come on, let me share it on screen. I need you guys to feel the kind of vibe I'm feeling right now. Okay, now you can see my screen. Okay, so you have one, two, three. So this is OH, one, two, this is H. This is what we call primary. Secondary, one, two, three. So I have OH in the middle. Remember, that's the rule. And I have H here. Okay, so carbon can never go and meet carbon and say, carbon, who out there, who you be? You get mine? No, like. So one, two, three, OH in the middle again. Again, another carbon, CH3. So this is, so you see, oxidizable hydrogen. That's oxidation. Come on, guys. Oh, come on, everybody just floating on my screen. That makes a lot of sense. So here, you see, how many oxidizable hydrogen do we have? That's what we are going to call it. In the primary, we have two oxidizable hydrogen. That what makes it a primary alcohol. In secondary alcohol, we have only one oxidizable, only one hydrogen can leave. Remember in SS2, your teacher was teaching you oxidation and reduction. Oxidation is loss of electron, reduction is gain of electron, oxidation is the addition of oxygen and removal of hydrogen. Of course, we are removing hydrogen. That means we are simply saying oxidation. Yeah, you see, it has come to play. In organic chemistry, when we are just talking about oxidation, we are just talking about oxidation in terms of oxygen and hydrogen transfer. Okay, nobody cares. That's all. So, but look at it here. In this tertiary, this one at the bottom is a tertiary alcohol. There is no oxidizable hydrogen atom directly attached to that carbon that is holding that functional group. Why? Because carbon here, carbon here, carbon here, all of them have the same electronegativity. So carbon cannot go and tell carbon, oh yeah, you shift, give me your electron. It's not possible. It doesn't have that power. Carbon can only do that to hydrogen because hydrogen doesn't have power at all. Okay, so that's where we talk about primary, secondary, and tertiary. So in a case where you have gone to your JAM questions, yeah, sharing is going to be close. Yeah. Okay, this is where. In the case you have seen as an example, which of these which of these alcohols can undergo oxidation? Primary alcohols will undergo oxidation, secondary alcohols will undergo oxidation, but tertiary alcohols cannot undergo oxidation. Why? Because there is no enough oxidizable hydrogen atoms there. Nobody will ask you the reason, but because it's objective, they'll just tell you A, B, C, D. And then, in what way do they, if it is why I usually confuse students just to see if they understand how, they will not look at what I'm going to write. CH3, C, let me, OA, CH, let me just correct this. Let me see how I'm going to do CH, yeah, I got it. CH3, OH. Okay, so this is what I will do. CH3OH. They put it, so that means that simply means that all these CH3 here are attached to one single carbon. That is what that means. So that means it is this guy on the right hand side. So whenever you see this kind of thing, just know that they are tricking you. They want to find out if you are conversant with the primary alcohols and secondary alcohol and tertiary alcohols. Okay, that's kind of easy to remember. Okay, so that is one other thing. So you can add that to say you can have CH3, CH, CH3, OH, CH3. So I'm going to put this on in bracket. So you see, whenever you see this kind of thing like this, automatically is a secondary alcohol. OH is in the middle. It cannot be in front because the last carbon here. See, I always tell them, what do you do? Whenever they put CH3 in bracket, that simply means that it's a substituent. It's an attachment. So it's attached. So all you need to do, look for all those carbon that are not in brackets, write them out. This is carbon number 1, so write it. This is carbon number 2, not that. This is carbon number 3. So that's how you do it. So this CH3, you put it either up or down. OH. Okay, I think I made that. I must have. There's not supposed to be H here, so forgive me. Let me say. So this is an OH here. OH becomes at the bottom here. So that is at the weapons. Okay, can you see? So whenever it's bracket, it simply means that is an attachment. Okay, so that is. So I've answered 3 core questions. I'll be able to help you to differentiate between primary alcohols, secondary alcohols, and tertiary alcohols. I'll be able to show you that primary alcohols can be oxidized, secondary alcohols can be oxidized, but tertiary alcohols cannot be oxidized. I hope you have gotten that. And then the question that WAEC will always ask you, the JAMB will ask you, what is the degree of oxidation? What is the degree of oxidation? Let's go back to primary alcohols. Look at these primary alcohols. I told you here that it has only one oxidizable hydrogen atom. That means I can only remove this hydrogen to join it with this guy. So when I oxidize it, can you see what it has formed? So there is no other one I can oxidize. Just 1 degree, just 1 oxidation. So when it oxidizes it, it changes the compounds to an alkanone. Alkanone. If it is propanol, it's propan-2-ol will oxidize to propan-2-one. That's propanone. Okay, so if it is just 1 oxidizable hydrogen atom, let me go to secondary alcohol, primary alcohol, just a moment. So secondary alcohols cannot be primary. See these primary alcohols, can you see? It can still undergo further oxidation. You see, this is just stage 1. Let me clean this thing. You can see here that I can still have this. I can still have this oxidizable alcohol. You can see oxidizable hydrogen is here. That means I can still do a further oxidation. I remove this hydrogen because it's still shaking, because oxygen here cannot be trusted. So once anything happens, I can still oxidize this one further to give me ethanoic acid. I can't touch this one, obviously, because carbon is very stubborn. C double bond to O, then to OH. See, oxidation is the removal of hydrogen. It can also be defined as the addition of oxygen. So you see, I've added 1 additional oxygen here, but of course, it's just the condition I'm oxidizing it. So you can see here that there's an intermediate here. So why question now? JAMB question, you will see this glaring to your face. They will tell you complete oxidation, partial oxidation. What is the product form when there is a partial oxidation of a primary alcohol? So it's an alkanol. See, that's ethanol. Ethanol gives you ethanol. On complete oxidation, it will be oxidized to ethanoic acid. Ethanoic acid. Okay, very, very simple. Just make sure that you remember this. So I've given you some very interesting WAEC answers now. So if you have questions about this, just send it on the chat. I will try my best to read it. Okay, so another thing before, I don't know, I hate this time something. So we are treating germ now. Where is our source? Because I called it organic chemistry. They are all obtained from plants. So how can I produce ethanol? Very simple. This is jam. So don't need to memorize anything. Don't need to learn any mechanism. Hydration, jam question. Hydration means you are adding water. When your test is I am dehydrated. Now I have a lot of water in my body. I am hydrated. So you see, you can play with chemistry words at home. So you can hydrate with an ethene, or you can dehydrate sugar. Did I say that? Yeah, that's very correct. You see, 2 key words. Was that correct? Was that correct? Was that correct? Was that correct? No, no. That is very wrong. You can hydrate an ethene. You can ferment sugar. That's correct. If you dehydrate sugar, you get sugar charcoal. Remember that your teacher before you can't give it to your teacher now. You insult me. I said that guy doesn't know what he's teaching. If you dehydrate sugar, it gives you sugar charcoal. That means if you remove all the water in sugar, I'm sure you remember that sugar charcoal, animal charcoal that you did the SS1 taught them. Yeah, this is it. If you dehydrate sugar, you give sugar charcoal. So forgive me, that was my baby mistake. But when you ferment means you expose it to microorganisms like yeast. Yeah, enzymes. So if you expose that to microorganisms like enzymes, it will undergo fermentation. And that fermentation is sugar charcoal sweet? Never. I tried produce. You can do it in your chemistry lab if your teacher permits you. Sugar charcoal like um think about it. You just got a cube of sugar. So you go to your chemistry lab, just grab 1 cube of sugar or 2 cubes of sugar. Then tell your teacher that please, I have this experiment that can you really show me this? Do we have concentrated sulfuric acid in the lab? You say yes. But you allow your teacher to do it because it can burn you. Just put a drop of concentrated sulfuric acid on the sugar. Sulfuric acid, though. You remember that I don't want to call it ibuprofen. Tetraoxosulfate, cis acid. You know that acid I used to make mouth with to conscious students when you learned it in SS1. So sulfuric acid, just put a drop of it. It will just turn the whole thing like to black. So we call it char. It will turn it to black. And of course, you can't eat it. Yeah, it's acid that has touched it. So somebody asked, what is the phenomenon? What causes this phenomenon? Oh, have you seen this question in why before? Have you heard of drying agent before? I know you have heard of it. Drying agent, and then agents, and we also have dehydrating. Because in chemistry, we are just playing around things. We just want to know what is happening here. Just do different things. If you want to dry something, just put it on that sun. It will dry. Yeah, Abby. It will remove all the water. It You dry your gari, you remove all the water. The gari is still gari. Nothing happened to the gari. But dehydrate means that you remove all the water in that glucose. What will be left? Carbon. So it's a chemical process. So just get dehydrating removes. So in the exam, dehydrating removes all the elements. See, it's a chemical process, chemical reaction. Dehydrating is a chemical process that removes all the elements that can form water in a given compound. While drying, just remove any water molecule that is present in that compound. So leave all those things. We are talking about fermentation here. I'm not interested in so ethanol, nobody's interested in it. So this is the equation that you should be watching out for. Watch out for these equations if you are doing WAEC and you're also doing JAM. So this is just simply chemical. This is the hydration equation. WAEC will never ask you about this second equation. WAEC is only interested in these two equations. This is the dehydration that is in stages. Dehydration, hydration. You see, hydration. So you react with sulfuric acid, it forms this intermediate. You add more water, it forms the ethanol for you. Okay, that's what WAEC is interested. Those of you that did that GCSE, it is IGCSE that is interested in this reaction. In the IGCSE, they ask you what are the conditions. JAM, yes, JAM is interested in this second reaction because they don't have space to be typing plenty questions. So they just say which of the following equation represents hydration of alcohol, hydration of ethene. Okay. So I can use charcoal sugar as an absorbent. Yeah, of course, that's one of the major things. So what we just need is what we just simply need is that we just have to turn it to charcoal. And of course, all those charcoal have pores in between them. And those pores have spaces. So they can either if you use them for absorbent, but not absorbent in terms of using it for the things that you're going to eat and chew. So there are natural ways of doing absorbent. Just get your wood, burn it, and you get your normal wood charcoal. So that's kind of easier to use for as an absorbent if you are taking away poisonous gases or colors. Okay, so it's only WAEC that is interested in this commercial production fermentation. But what is JAM interested in? This is where JAM is interested in. This is where you see JAM questions now. In JAM questions under this topic, JAM will be asking you, what is this enzyme called? What is this enzyme? I'm circling it now. And what is this enzyme called? So that is what JAM is interested in. WAEC can tell you that I should describe these whole stages. But JAM will tell you what is the enzyme that is responsible for the conversion of glucose to alcohol is zymase. That's what JAM is interested in. JAM is interested in which enzyme breaks starch. breaks down starch to maltose. Not particular. I don't think jam is really interesting. I think I've seen this question only once in jam, but this number 5 one is the one that is most prominent. Okay, so that is the cuckoo. I think yeah, it's in the next slide, and the next question is in the next slide. Another question is here that Jam will ask you which of the following formula represents starch. So take note of the starch formula: C6H5 H10O5. See, so take note of that. Okay, so that is another question I know I've seen in the past for Jam. The next slide, yeah, this is the another slide that Jam is interested in. Yes, invertase. What's the role of invertase? Convert glucose to two monomers. You know, I talk about polymers here. So two monomers, glucose and fructose. Okay, so that is exactly what happens here. So this is the two slides that WAEC and JAM is interested in. If it is WAEC will just tell you that you should learn this. In recent time, WAEC is focusing their attention in this equation. So that students don't have to cram so many equations, before they can get one question. Okay, so that is what you are interested in. These are physical properties of ethanol. Remember that thing I used to talk about alcohols being able to be dissolve in water to have high boiling point is simply because of the hydroxy group. Why? The hydroxy group contains hydrogen bonding. Okay, so that is another jam question here. You can see, so the hydrogen bonding here is another jam question. And of course, again, that is another jam question. So jam, they can arrange C for H10, C3H8, C. Oh no, I don't. I'm not getting. Okay, let me know. Let me remove this C4H10. Uh-oh. Let me clean this one. I don't think this is the way Jam will present it. Let me show you what they do. They'll now do this one. Okay. C3H6, C3H4, C3H7OH. Alkanes, alcohols, and alkynes. They'll now say which one has the highest boiling points. Of course, brothers and sisters, the one that has OH has hydrogen bonding, and that makes it very strong. And okay, so that is quite easy. Okay, so that is how they arrange it. I say which one has the highest boiling point and which one has the lowest boiling point. So you obviously know the one that has less bonding, like propane. Yeah, propane has the lowest boiling point. Okay, so that's very easy. Um, Chemical properties of alcohols. Which one is important here? Yeah, I've seen this one. This one is wire question. Yeah, this is wire question. They always ask you to write the equation. Combustion is common. Combustion is one chemical reaction that is common to all. Let me just say all organic compounds because they can bond them. So organic compounds can easily bond, and when they bond, they produce carbon dioxide and water. So that is a common question, general question. If you cannot remember anything in WAEC, if you are doing WAEC, just remember that combustion reaction. If you cannot remember anything for yeah, why the second one too is why question. Why is it why question? Because they are treating alcohol with sodium. Once you treat alcohol with sodium, you are definitely looking for why is interested in the gas produced because they want to be sure that students understand. So they will now begin to tell you a gas is see both of them produces gas. So this one is also producing gas. So they were like a gas, colorless odorless gas that makes a pop sound when lighted in a splinter. So they're interested in this hydrogen gas produced. Jam is interested in the product, this sodium hydroxide here. That's what Jam is interested in. Okay. I've seen it in Jam past question. That's what I'm really saying. I deliberately wrote this second equation to represent whatever I'm saying. Why? Because WAEC wanted to be sure that you still understand the concept of oxidation state, that calcium has a +2 oxidation state and sodium has a +1 oxidation state. So they know that this is the one that students are conversant with. They now give you this one. And they're now trying to see if you can remember that oxidation state, that oxygen that I wrote in that time has just a negative charge. So to see if you're able to balance the oxidation state. And that was why they brought out this question in WAEC in the past. Okay, so I don't want to buy too much time. Yeah, I talked about oxidation of alcohols Yes, primary alcohol, secondary alcohols. I've repeated myself here for you to remember. Okay, so in JAMB, how we JAMB express it, they say in the presence of excess, okay, excess, in the presence of excess oxidizing agent, or in the presence of excess. So whenever you hear something like this excess, that means they're talking about the final product. So remember, this is an intermediate product, and this one can still go to CH3COOH. Remember, I told you this thing earlier. So primary alcohols can be oxidized to ethanol and further oxidation to ethanoic acid. Okay, so I said on further oxidation in presence of this acid, ethanol is converted. I think I've done that already. This is why question. Nobody cares about that anymore. And I've told you the rest about the oxidation. The most important reaction that alcohols undergo is this esterification reaction, and that was what's supposed to lead me to formation of esters. I won't waste time because time is against me, and I need to like round up. I told you. So, so before I some let me just mention this. Some people were talking about physics class, physics class, physics class, physics class. So finally, I got into a friend of mine who's an expert in physics. So because they're on Easter break, I don't know if everybody's on Easter break, but that my friend is also very busy on weekends. So I told him that since this is free, he can choose any day next week, any day of the week next week. So I'm going to put a poll. So I'll put a poll on the WhatsApp. Just pick the day that is convenient for you, Easter Monday, Easter Tuesday, blah, 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 that you want us to have that physics class. The same link, everything is the same. You just come, bring your questions on physics day. Okay, so that is it. But this is the most important question that you keep seeing everywhere in WAEC, in JAM. This question. It is simply esterification. Like, if you cannot remember anything about this, just remember that this is what Dama said, that is esterification comes out virtually every year. I don't know why, but it's just like it. Why? Because it's a very important reaction for alkanols that they react with alkanoic acid, and it's a reversible reaction. And funny enough, it produces a very unique class of organic compound that we use in making paints. Because paint is very, very interesting. Like, paint is one of the most useful things that you have, making your environment to be really nice. And also, and this compound also present in fruits. They give all those fruits that eat their unique smell. Like if you take orange, this is orange. This is banana. This is mango. How do you differentiate that? It is because they are called esters that are responsible for that. Oh, this is tomatoes, is esters. So when alcohols react with alkanoic acid, so the question is, what kind of question can WAEC ask me? Yeah, WAEC can ask you to define esterification. It's a reversible reaction between an alkanoic acid and carboxylic and an alkanol in the presence of mineral acids to form esters. Okay, so that's how you define it. The fourth reaction is esterification. That reaction, we can decouple it, that like we can break it down to break down the ester to give us the original thing, either using an acid or using a base. So if you use an acid, we call it hydrolysis, acid hydrolysis. If you use a base, it's called base hydrolysis. Yeah. Of course, one thing I want to point out, we also have esters in oil, not like palm oil, groundnut oil. Yeah, those ones are also esters. But the own ester have very long carbon chain. So very short carbon chain will give you, see, I'm giving you tips now. Short carbon chain esters will give you soap. Yeah, that's wrong. Will give you salt. Long carbon chain esters will give you soap. Okay, so I think that's those things that are contained in the PDF that I sent on WhatsApp. Okay, so let me just teach you one secret on how to decouple it. Remember what Mr Nkwocha said, the easiest route. See what I'm going to do. Let me break this out down for you people. Let me go to my screen and share it with a whiteboard and show you how you do this thing. Very simple. Okay. Okay, so let's bring that Alkanols, CCOH. Okay, let me just put all these things are hydrogen. I don't care about hydrogen, but I care about the functional group. Let me bring the carboxylic acid, C, double bond to O, single bond to O, single bond to AH. So my brothers and my sisters, these two guys are supposed to react, and they're supposed to give us an ester and water. Ester and water. So look at what I always say. So there are different ways you can do this. So what are the different ways you can do this? Well, what do you do? How do I form the product? You remember, one of my products is going to be water. So I'll just write this water on the right-hand side here. That's what you do. You remember that I told you that it is at the functional group that this chemical, somebody is asking me for the link by this time. Really? Damn. Oh no, I don't know what I'm going to do to this person. How do you send me link for this lesson by this time? And I pinned it on the WhatsApp group. Oh, okay. So look at what I usually do. So this is the alcohol that contains OH. I remember I told you that the functional group of the alcohol will break. So it will break it. Pim, 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 pim. Hydrogen will run away. Yes. That's one of the easiest way I remember. Hydrogen will run away. So you want hydrogen, once hydrogen runs away, it has to look for a friend to beg. You cannot beg any of these ones that are at the back here. So it goes to this other guy here. He said, okay, guys, let's combine. Okay, so they're combining. So this hydrogen here combines with this OH here to form water. So that means what is our ester? So take note of what I'm going to do. I need to write the alkanoic acid one first because hydrogen. Why? Because it brought two things that left. That's the only reason I can give to you. Yeah, I don't have to talk about the mechanism because it's not necessary. So it should be written first. Why? Because he's at least he's losing two people. So let's give honor to him. At least he lost two people. So let's give honor to him. So you have CH3 there, CO. So let us now connect these other guys together. So we now come and connect O. You connect it from the back. You now have CH2, CH3. You see, that's what I did. That's the usual way I usually do it for people to remember. So you remove the hydrogen. In fact, some people in the past have, I think what people usually do, let me tell you what they used to do. They'll just remove the OH together completely. Yeah, that is what people do actually. So they'll just remove the OH completely from the alcohol. They just remove the OH completely from the alcohol and just connect only the carbon to the carboxylic group. So they will now come here and remove only the hydrogen. So which one is easy for you? Remove all the OH from this guy and carry the bare carbon and come and put it at the end here to replace this hydrogen. Is that what you like? Fine. Okay, so I'm going to give you a very simple task now for you to choose the one that you want to do. Okay, so let's go to that. Okay, so let me give you your own to practice. So let's say, for example, I have CH3. There's my pen. C, yeah, CH3, CH2, CH2, OH. So let me ask you, plus CH3, COOH. So how do you form your own ester? Remember there are two things that I've showed you. So I told you that my friends, they will go to the alcohol and remove the OH so that they will not get confused. Since they know that they are obviously going to carry it and put it. You can put your answer on the chat. What should be your ester be? So the easiest thing to do is to remove the OH here so you don't get confused. Remove the OH on the alcohol and let it combine with this hydrogen here. So it's easy for you to fix. So obviously, so do you know why it's easy it's easy that way? Because if I should remove, once you move this OH, that means that the bond here has gone with this oxygen and this carbon has become positive. And once this one becomes negative, that's very easy for you to remember. So once you move this hydrogen, that is negative. that becomes negative. But once you remove this oxygen, that carbon automatically becomes positive. That's a very fantastic way to do it. So what you need to do, so for you to write your product becomes CH3, COO. See, I've written the carboxylic acid part that is remaining. I will now, the remaining carbon chain that is left is what I am going to now bring. I now bring CH2. That positive part is what I'm going to write CH2. I'll reverse it and I put CH3. Okay, so that's how you simply form your ester. Okay, very, very simple. And the other question that they will ask you is for you to name it. And when you are naming it, it's the same thing. Who is the person that came to join and extended our organic chain? It is this guy here. This one that came to join. You tell, so what is the name here? You ask three carbon. 1, 2, 3. So you call it propyl. Propyl. This other carbon, the remaining part is 1, 2. That's two carbon, that's ether. Propyl ethanoate. Okay, so that is how esters are deliberately formed. Okay, so 7:15, our time is kind of up. I don't know how you guys feel about this class, but unfortunately, this 1 hour is not enough for us to like finish all that I want to teach you. So you get what I've done. Like I told you, I've taught this topics time without number. I'm going to post the remaining part of this class on the YouTube link and on YouTube, and I'll share the link with you. That's fun, right? So, and then you can go through the notes. The notes are really kind of explanatory. I know you already have textbook. You can go through the notes and then ask questions on WhatsApp to me. Once you're confused about anything, once you need me to, oh, Mr. Nkwocha, please, can you explain this thing? I don't know what this is talking about. Can you, I will just put the topic or whatever is confusing you, no matter where the topic is coming from, just put it on WhatsApp. You can drop it on the group chat, or you can private chat me. Yeah, there's nothing really there. No big deal. And I will do my best to respond to you as soon as possible. I know you're all burning your data right now, and I just feel like it's important I end the class. So, but before I end the class, if you have any questions, you can drop it right now. Let me just show you. Okay, use of alcohol for those of you that are doing WAEC, no big deal. This is just like some WAEC past questions. See what WAEC you ask, what is fermentation, name the catalyst used. How can you convert these alcohols? You see, this is WAEC question. See what WAEC is asking. This is alkene converted to alcohol. So they asked you to give the reagent. I think we did it. So all what you need to do is add sulfuric acid and water. Remember? Yeah. Then this is alcohol converted to alkanoic acid. What is the reagent needed? KMNO4. Oxidized reagent, KMNO4 and H2SO4 together. Or K2Cr2O7, that's potassium dichromate and H2SO4. Look at this one now. Alkanoic acid, how do you convert this into ester? What is the reagent needed? You see, this is an ester. Not on the right hand side is an ester. So what is the reagent needed? You need an alkanol. So you need to tell us what kind of alkanol. This one has only uh, two carbon. See? Two carbon. That means we need an ethanol. Because that is the alkanol part. So you need an ethanol. You need H2SO4 for you to score your full mark. See, this is another question that I saw in WAEC. This is the trick students for them to be able to show which one is stay the class, whether it's primary, secondary, or tertiary. You see, all of them are monohydric. So it is your job to draw this structure and find out. See, this one has 2 CH in the bracket, so that means it's going to be tertiary. So the first one is going to be tertiary. The second one, once you have a bracket, automatically you are having a branch now. Okay, so the first one is tertiary. The second one, you see, the OH is on the first carbon, that's primary. You see? And then the third one is secondary. So you see, this is the reaction that I was talking about. You see, they gave you potassium here now. to show that you should remember, you need to identify the reaction center. And of course, the reaction center is this but hydrogen here. Substitute it. That is the simplest point. This one, see, this is the same esterification reaction I gave you as an example now. So take away this OH here and connect this remaining carbon to this space. Very simple. And this is oxidation. You see, they put it excess. They put it excess because they need to know the final point. All what you need to do, just remove this hydrogen here and put O extra. And of course, you have to remove two hydrogen anyway. So it gives you two hydrogen. So name the major product. So it is easy for you to answer both wire questions and jam questions. I haven't attended this class today. See, this is why question that talk about fermentation, blah 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 blah. What are state the byproduct carbon dioxide? What state uses on the byproduct? What do you use carbon dioxide for? Okay, you know what to do. You can answer that question. Google can also help you. Right? You can use it for dry ice for cooling. You can use carbon dioxide for extraction. You can also use carbon dioxide for fire extinguishers. Remember what you can use it for? Yeah. You can also use it for refrigerated drinks like Coke. So okay, so ethanol can be produced from cane sugar. That last, and also from petrol. That's cane that I showed you. So what is the difference between the two of them? Which one is renewable? Of course, the one from sugarcane is renewable because we can replant the sugarcane plant stem and get our sugarcane again. But the one obtained from petroleum is not renewable because once it is burnt, it is burnt. It cannot be restored. Which is that one? Let me see. Okay, so that's like first part. Second part is the carboxylic acids and esters. Uh, I don't know. Time is so quick vote. So type end the class now so I can end the class because I think I'm already exhausting my time. I can send the video of this class, end the class, keep going. So I can do esters. I think I've already done esters. It's just for me to like show you about the carboxylic acid if you want it. So it's up to you to tell me what you want on the chat before I run away. Papa, 5, 4, 3. Come on, guys. So you guys are not even paying attention to me. That's sad. I'm just joking. I know you are. Okay, so I guess we should just end the class here, right? So I will send, I already have videos for these other topics. So I can just send the link to you to watch on YouTube. And you can just trust me that this note is very, very explanatory. And you can just read through. I know you already know some of them. So you can play and practice on all of them and then put them as. If you have questions, just send it to me on WhatsApp. And I hope this is where I draw the curtain today. So thank you very much